Hey everybody, it's John here, John's DIY Playground. Today I'm going to show you what I am calling my utility room moat. It's a sensor node that I created for my home automation network, and this is what it looks like from the front side. And on the back, I've got input for power, and I've got an input for a number of sensors. You can see there's something for the dryer, a couple of water sensors, output to a water heater. We'll cover all that in the video today. It's based on the Motino, which is an Arduino type of AVR. It's got a little beeper on there, and it's got the first circuit board I ever did myself, and I'm very proud of that, so I'll share that with you. So I will talk about today what my idea was about how this thing should work, how I created a flow chart of how it should work then, and that's how I come up with my my software, and then building up a circuit schematic in KiCAD, which is the program I used to make the circuit board, and then putting it all together. The components and the hardware I used and selected, the software, we'll go through software in detail, and then the extras on the actual gateway that allow this thing to talk to it and understand what it's saying, and the other things that I do for like automatic alerts and whatnot. So hope you stick around and enjoy this. Let's get started. Alright guys, so hopefully my handwriting's not too messy here for you, but this is really the real deal, how I came up with this idea for the utility room moat. And basically when I come up with an idea like this, especially where I need to write some software, is I really got to get my ideas down on paper. So with that, I started in the upper right corner of like thinking about what are my inputs and outputs going to be so I can write my flow chart. So I want to have a dryer status and know if the clothes dryer is going to be off or on, so that's an input. A hot water heater off or on is an output. So that's a controller. I'm going to send a signal to a relay and switch my hot water heater on or off so I can control it remotely. Another input is a water heater leak sensor that will be sitting on the floor. We'll show how that works in the hardware part of this video later. True or false for that. And then another input, same type of sensor but by my washing machine, so I can detect a leak there. They're very close to each other, but I wanted to have sensors close to each device, so the water heater and the washing machine in this case. Then as I was thinking a little further what kind of hardware I wanted to use, of course the Motino is my brains that accepts the software and runs the processing of the inputs and outputs. I would need some resistor and capacitor circuits for detecting dryer status. Wires for the low voltage relay to control the heater output. Thinking about using audio jacks for plugging in the sensors easily and removing them easily. And then wires out again for the water sensors, a couple of pair of wires for each water sensor, and using audio jacks again as my quick connect for those to my box. And then audio sensor for the dryer, which is actually two wires that's going to run out to a current sensing loop. We'll show that also later in the video in the hardware section. And then I also made sure I want to have two LEDs, one to show that the dryer is actually being detected that it's running, and the other one to flash a light at me and let me know that if there's a water leak. It'll also beep too. I didn't mention that in this hardware list. So then from there I go and start writing my routine, and this flow chart's not overly complicated. It's just a one-pager. Couldn't show it all on the screen here, but I'll scroll down in a minute. And really when you're writing software for these sensors and Motinos, you're going to be in a continuous loop, right? So you have to think that you're going to go through something maybe in the beginning just one time in the initialization part of the code, but then once you hit the loop, you're going to keep doing these things over and over again. So what I've done here is, first thing in my flash area of the code is I'm looking for this wireless flag so I can reflash possibly wirelessly. That's a feature that the Motino has. It's able to be flashed over the air without connecting wires physically to it once you have this software loaded. So I only need to load the software by wire one time. If it does see that flag, then it goes and does the reflash and restarts the whole thing over. So then we go into the next part. Another decision is my incoming control message for the water heater. So do I want to turn my water heater relay on or off? And if it's a yes, very simply turn it on. And I'm also going to monitor status of that. If it's no, then move on to the next thing. So let me scroll down here. So next is a kind of a check your inputs loop. I'm looking for the dryer status to see if that's on or off. I'm looking for the water heaters leak detector and the washing machine leak detector, seeing if those things are on or off. And then just kind of making some flags and notes for myself. This isn't really flow chart normal symbols that you would use in a flow chart, but I'm just kind of noting, hey, if either water leak sensor is true, then start beeping that beeper and turn on the LED. The dryer's on, turn on the dryer LED. So this flow chart isn't perfect, but it's kind of, my first stab at what I thought I wanted to do when I was going to write the code. So I always have to do this before I write the code, otherwise I'm lost. Anyway, I'm setting some statuses here. If anything is changing status, set it flag to true. This is where I actually use the Motino's wireless feature to transmit to my DIY gateway, which has another Motino to receive the signals, and it's attached to a Raspberry Pi. And that's where I can see on my gateway if the water leaks are positive or if the dryer's done or what's happening with each one of the sensors. It'll only transmit if something has changed status, so I wanted to make sure I did that and not keep transmitting over and over again, because then I'd just be overloading my network with a flood of messages with no status change. It just keeps saying true, 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 or false, false, false. And then basically I'm looking to reset all of my flags at the end, because I'm going to recheck and reread them when I come back around the loop again. So that's just kind of the end of my loop before I go back up to the top. So that's all there is to this code. There's no physical buttons or inputs that the human touches. That's just reading sensors that are electronic. And what I'll do next is show you what my schematic ended up looking like, because that was my next step in bits and pieces, trying to figure out exactly what hardware I needed so that I would know kind of how I wanted to write my software as well. So let's get into that part of it next. Alright guys, so this is the circuit I drew up using a program called KiCAD, K-I-C-A-D. I learned how to use it really quickly just using YouTube tutorials, kind of like this one. I won't go into exactly the details of using KiCAD. It would take me forever to do that, but just for explanation of what my sensor does and the hardware that's involved. The heart of this thing, like I said, is the Motino. And the Motino has its own unique pinout. You need to look it up and understand a few things if you're going to use Motino, because if you have the radio transmitter feature on it, the pins are open on it for you to use as it looks, but you should not use them. So for example, I'm going to show you a few of these pins here, and there's a reason why I don't have anything connected to them. So if we go ahead and pop up real quick the pinout of what a Motino looks like as far as the hardware, you'll see this note over here that says if it has one asterisk, it's used by the radio transceiver. So you cannot use pins digital 2, digital 10, 11, 12, or 13. So you can see here the asterisk. You cannot hook anything to this because they're already being used by the transceiver. So just keep that in mind when you're designing your circuit if you're using Motino, to not use any of those asterisk out input outputs. Okay, so with that, let's look at this schematic real quick. It's pretty simple. Just kind of starting in the upper right here, I have my input power. Anything from like 5 volt to 9 volt is fine for this. It has its own 3.3 voltage regulator on board, so I'm just bringing power in this way. And then kind of moving counterclockwise around this thing. I'm using pin 3 as my buzzer output, so I can beep when the water leaks are detected, or when the cycle of the dryer ends, I'll also beep. Water heater relay, this is the output to the water heater relay where I can turn my water heater on and off, so I'm using a digital pin 7 for that. And then these are the LEDs that are in the front of my box, the LED leak sensor, so if there's any water leaks from either the hot water heater or the heater near the washing machine leak detector, I'm sorry. And then the other LED is a green LED that'll be on when the dryer is on, just to show me that the sensor is working. Moving over to this section, this one is actually the dryer circuit that detects the current coming in. So I'm using a voltage divider, and basically that voltage goes into this analog read 0. So I'm going to read plus or minus 1 volt here. And I have to show you some filtering in my software code because it's really reading an AC circuit. So this voltage is constantly fluctuating between -1 to 1 volt approximately. So I have to do special methods to detect if the dryer is actually running or not. Then over here, this is really 2 copies of the same section of the circuit. I kind of borrowed this from someone I found online who was doing water leak detection as well, but it's really just a transistor with a couple of resistors, and then your leak sensor is nothing more than running a couple of wires out to the ground. I'll show a picture of what I designed for my place just to put on the ground. Then I run 2 wires to an audio jack and plug it in here, and I have a sensor, like I said, for my washing machine by there, and then one by the hot water heater. So those feed into these analog inputs as well. And that's it. That's all there is to the circuit. KiCAD was a great program to learn for me because with the same software, and it's free by the way, you can then take your schematic and create a circuit board. So I created a 2-layer circuit board, and let me show you that real quick just on the screen. And this is an amazing program. I can't say enough about it. I can't believe it's free. This program is called PCB New. It is part of the KiCAD package that comes with that free download that you do the schematic, and then the next step is to come here. You define the size of your board. In my case, it's about a 2-inch by 2-inch board. I placed 4 mounting holes so I can put screws through here and mount it to my case. And then you start placing your components. So for me, all my components are through hole because I'm old school. And that's pretty much what I have laying around my house. But KiCAD in this program is just awesome because you can control the placement of the parts, and you can label the silk screens how you want, so how things will look in print on the board, exactly where you want the components to be, and then you can do the routings manually, or it has an auto routing, which I don't know if it's that great. But one excellent feature is once you have this all laid out and you've got all your components on and hooked up where they need to go, it has this great 3D viewer, and this thing renders right away. And look at this, it's amazing. So just like that, gives you an idea of what your board's going to look like. So you can flip it around, have a look at and make sure everything looks as you expect. And yeah, this is just cool. I mean, I used to do boards by hand where I'd take a copper clad board and start writing traces with an ink pen, a resist pen, or I would use later in time I used toner transfer method and then dipped it in acid. But from here, when this is done, you can output Gerber files, and then you put them into a zip file and you send them to a prototype house like OSH Park, for example, and for $20 they'll make 3 copies of this board, double-sided, with all the silk screens and the labels. I'll show you what that looks like in a picture here next, but it comes out just beautiful. And man, for 20 bucks, it's perfect. So this is the first one I've ever done like that, and I'm really happy with the results. In the future, I'd like to try some surface mount stuff, but for now, this really fits the bill. This is the board, one of 3 copies that I got back from OSH Park, and 3 copies is the minimum order quantity. I only needed 1, but oh well, whatever. $20 including shipping for all 3 boards, so no big deal. But you can see the front side's beautiful. I mean, this is the top side. It's got all the silk screening. Through holes look great. Everything turned out really nice. I even did a copper flood in here on the top and bottom sides, so looks really nice. And then to take a look real quick at the bottom side here, same thing. Nothing to be labeled because I didn't populate any components on the bottom, but just to put a label on there, I put that on the silk screen. So that's it. Looks great. Let's move on to the other hardware. This is my sensor hardware that I'm using for the project. I've got on the one hand this circuit transformer, or current transformer, I'm sorry, called SCT013, good for 30 amps. It puts out up to 1 volt. And basically you just unclamp this and put it around a single wire. It's got magnets on both sides, and then a coil of wire here you clamp down so that the wire's passing through. Detects the AC current, so that's how you know when the dryer's on or off. I'll show you how I have that hooked up in a second. And then secondly, this is the water detector part of it. Really simple. It's just 2 wires going to a phone jack, headphone jack, and then I've got it on this circuit board material that's just perf board, and hopefully you can see that. But it's just 2 wires side by side. When water crosses the 2 terminals, it closes the circuit and we detect water. So real quick, this is my laundry dryer setup. I've got the thing opened up. I took the lid of the dryer and popped it open. So we're looking down inside my dryer here. It's an electric dryer. Well, it's natural gas fired, but it's got electricity to spin the drums. So right here is my current sensor, and I got that hooked to one of the power lines that's powering the dryer, and then I've got a grommet that I drilled into the side of the dryer to pass the wire through. So there's a nice rubber grommet to protect the wire from getting cut. And that leads to my sensor box. This is the software I wrote for the utility room remote. I'm going to post it on GitHub, and I'll put a link to where the code is located in the info box below my video. So check that out if you'd like to get the entire code. Managed to get it to be about 250 lines. Take out all the comments and it'll be even less than that. But I'll just kind of graze over some of the highlights of this code and show you how it works. So you can hopefully understand it. I try to comment it as much as I can. Really, the front end of these parts of the code are just initializations and libraries that you can download from Low Power Lab. By the way, I'm formatting and putting all this code into a website called codebender.cc. It's really nice because they do the line numbering and all the format recognition with the color coding by itself. It happens automatically, so it's really nice for writing software and debugging. Anyway, these are more or less standard things that I put in this start of a Motino-based sensor node, and then this is also very standard down here where we need to enter in a few different things to get it to talk to our main gateway. You have to have the ID number of the gateway. The node ID is just a unique number. For this particular sensor I chose 99. Network ID also has to match all the other sensors if they're going to be talking within the same area, giving commands to each other. So that should be the same for all the sensors in your house usually. As far as this frequency, this is the frequency of the transceiver. When you buy a Motino, you can buy them with different radio frequencies. My particular flavor is the 915 megahertz, so that's why I don't have that line commented out. Encryption key, very important. Has to be the same on all of your sensor nodes and on your gateway. It has to be 16 characters, so change this section to that. It can be numbers, letters, whatever, but 16 characters. Then we've got some code here just about for debugging, so we can watch things on a console if we need to debug. Still in the initialization section, we're talking and telling what our outputs are going to be. In inputs, my leak sensor, pin 5, my LED dryer, digital pin 6, my buzzer pin on output, digital pin 3, so all 3 of those are actually outputs. Those water heater relays and output. And then my inputs, these sensors, leak sensor 1 and 2 for my for my washing machine and for my water heater. And the dryer sensor is on analog pin 0. As I mentioned earlier, the dryer sensor has AC current going through it, so it's going to vary between -1 and 1 volts. I need to take a number of readings and sample so that I know if it's actually on or off. We'll get into that a little bit further down the code, but I sample 5 readings in this case. Some of these other ones are for our flags that we talked about earlier in the flowchart. We've got sensor values and sensor statuses, current sensor statuses, so for comparison if they changed or not. So that's how I know, for example, if I want to send a message over the air with the transceiver to the gateway or not, if the current status doesn't match the status that I just read. So that's what that's all about. And then this is initializing the radio, and then basically we tell the Motino what all of our sensors are going to be, if they're inputs or outputs, and on which pin in this section. When I initialize, I have a subroutine called beep, and that just basically said, hey, we're alive, we're going to start running. So my beeper just does 3 quick beeps. This gets the radio going, and then these are a couple of the final lines of initialization. Now this is the main loop, so when you saw my flow chart earlier in the video, that's really what this section of code from 106 onward covers. So if you look at that flow chart and then kind of compare to what's here, that's the whole idea of what we did. Is first, for example, we're looking for messages coming from the radio, from our gateway, to see if there's something that we need to process. So the first thing I do is I look for that flag that says, hey, I'm going to be reprogrammed, so let's reprogram over the air instead of by wire. It's really, really cool, especially if you got this box or this transceiver way up in an attic or in a garage or someplace far away from a computer. You don't have to disconnect it. You can just program over the air. So that's what that does. Some of the commands can ask for acknowledgments, so you know if the message was sent or not, so we look for acknowledgement. These are water heater commands here, whether the water heater should be on or off. There's a subroutine that I wrote also near the end of this loop called water heater relay power, just to turn it off or to turn it on. If it gets a message from my gateway, which is a command that I would send from my desktop or my web browser, that's how I can remotely turn on or off my water heater. Now, this area is where I read in the leak sensors for the water sensors to see if there's a water leak or not. And then I process them. I found that a value of 850 is really the threshold that I wanted to use. Usually it's a value between 0 and 1024. So we take different actions with these different if statements, just like the flow chart showed. Leak sensor 1 and leak sensor 2. Then moving on, we go on further to something a little bit more complicated, and that's the dryer sensor. Again, because it's an AC signal, we can go between a volt and negative volt. The dryer's not running. It really sits kind of in the middle. The values could be between 0 and 1024, and I found if I'm not running, I'm between 510 or 511. Well, the problem is if I take one sample and the dryer's running, I could still get 510 or 511 because the AC signal will cross the 0 threshold and I will still see these values. So what I do is I take a number of readings and then I do a little subtraction and look at the delta, take the absolute value, and then add that to a total, and then I do a comparison and say, you know, is my reading total greater than 8? If it is, hey, guess what? The dryer's on. So I will send a signal for that. And then if it's less than that, then it's going to be off. So I set the value to that. Then we do comparisons near the end here to see if there's any changes to things, decide what we're going to transmit or not. And so these are subroutines. The end of the main loop is really here on line 219. This is a transmit status subroutine loop. Then for that audio beeper, it's right here. And then the water heater relay, as I mentioned, that's a subroutine as well. So that's the code in a nutshell, 250 lines. And again, if you want to see this and download it for yourself, it'll be on my GitHub page in the info box below. So one last thing to wrap it up. In the file called Metricsjs that's part of your Raspberry Pi files that Felix developed on Low Power Labs for this whole system to work, you need to define your custom node and tell it what kind of controls you have. So one of the section areas, I have to say that I've got a thing called the utility room mode. I've got a couple of controls that says water heater off, a water heater on, so I have buttons to turn that water heater on and off. But more importantly, even if I don't want that, I need to be able to define for this file what my messages look like, so when the gateway receives them, it knows how to process them. So further up in the file, what I have is this set of commands here from line 134 through 142. My leak sensor if it's on or off. I use this, basically send a 9901 as the identification for leak sensor 1, since it's node number 99 and it's leak number 1, whatever. On, I send a value of 1. Off, I send a value of 0. So leak or no leak. Same thing for leak sensor 2. Send a 9903 for dryer sensor status, again on or off. And then the water heater relay, I use 9904. Again, following same thing, on or off. I do allow for graphing of these last two ones, of the dryer status and the water heater relay. So if you want to, on my particular sensor here, you can graph those last two items and see them over time when the things are on or off. So it's really nice. Very nice work from Felix at lowpowerlab.com.
Alright guys, so finally the moment of truth, the test and run through of this whole thing. You can see on my laptop I have this set up with the node status called John's utility room sensor. It's node number 99. I can plot the dryer status. I can see water leak sensors 1 and 2 are currently okay. I've got the water heater turned off. I'm not really using this feature right now, but I can remotely turn it on and off. You can see if I click it right there, it causes it to beep, turns the status to the water heater on, and then conversely I can hit it again. Receives the signal. You hear a little confirmation beep that the water heater's off. So then as far as testing the dryer, I just have to turn it on. You'll see this green light will turn on here. So just like so. I've got SMS events, so I get text messages when the dryer was to turn off. It'll also beep, so here you go. It beeps, and then shortly thereafter I would receive a text message. Status changes to dryer off. Now for the water sensors, I'll put one of them under water real quick, and you can see what happens. So the red light will beep, and it'll keep beeping until the status turns back to okay and it goes dry. And that beeper goes off, the red light goes off. I'll also get a text message for that if there's water leaks detected. So anyway, it's working great. Very happy with it, and hope you learned something. If you did, please give me a thumbs up for a like and subscribe to my videos so when new ones come out you'll be notified right away. Thanks for watching John's DIY Playground.